Number 1, it says, what is another name for BD? What kind of line is BD? A line segment. How do I know it's a segment? Because there's no arrows, just a straight line. So what is another name for this segment? DB, straight line. That's it. Number 2 says, what is another name for EA? Where am I getting this E from? The middle. But there's no dot there. It's understood, right? Okay, so what is another name for EA? AE. All right. What is another name for Ray AE? So pause. When I say Ray AE, what is the starting or the ending, depending on how you want to say it? What is the starting point for this ray? A, and it goes infinitely in the direction of E. So when we rename it, we want to have the same idea. When I rename it, will my arrow point to the left? No, I always point to the right. If I want to start in the same place, what letter would I pick? A, and then I want to go in the same direction as E. What is in the same direction as E? C. So AC is another name for Ray AE. All right, number 4, we're going to name a bunch of rays that start with the endpoint E. I haven't had a single class get this correct. If it's the endpoint, is it going to be listed E? Is it going to be listed first or second? First. So remember that your book calls it an endpoint. I call it a starting point. It's the same idea, same exact point. So let's name a ray that starts with E. EC is one of them. EB is another. I'm getting there. EB, EA, and then yes, ED. EA, and then ED. All right, we want to name 2 pairs of opposite rays. So if I said you have 2 pairs of socks, how many individual socks are you naming? 4 individual. So 2 pairs, it's going to include 2 rays each. Yes, sir? Oh, you have an answer. All right, go for it.
Wouldn't it could be like
EC and?
And then EA?
Correct. EC and EA is one of them. All right, which means the second pair would be? ED and EB. All right, and then the last one, name 1 pair of rays that are not opposite. There are so many answers. Let's just pick 1 ray to start with. Sure. EC is not with EB. What else is EC not opposite with? ED. All right. So if you look, the next part is like a chart. On the left is a picture, and on the right, we're going to fill in the names. All right. So let's say we wanted to name point B. How would I name this point? There's 2 ways to name it, right? What's one of them? Capital B, which is the easiest one, or point B. And that's it. If I want to name a line, we're going to name this all the ways we can. There are 7 of them. I think there's 7. Yes? Line what?
Line M.
Correct. So one of them, you could say the word line, and then M. Can I use the word line with any other letter? No. All right, so then what does the symbol look like to name this line? Don't overthink it.
Oh, it has 2 arrows.
Yeah, it's a line with arrows. That's all. All right, and then how many points do you use?
2.
Point, line, plane. Point you use 1, line you use 2. So does it matter which 2? No. So we could say WX. I'm gonna list all of them. You can list 1 if you want. You can list all of them. Doesn't bother me. What is another pair? We could name it XY, which we could reverse to YX. And then the last one we haven't named, YW, which can be reversed to WY. So there are 7 ways to name this line. Can I ever name it with 3 letters? No, super ugly. Questions, comments, concerns? Wonderful. A plane. Whenever we're naming a plane, what do we always have to write? Plane. And then if I wanted to name it with 1 letter, what would that letter be? P. Or I could name it with points. How many points would it have to be? 3. What's a point I can't use? S. Why not? It's not on the plane. Can't use it to name the plane. And then I can't use P because it's the name of the plane. It's not a point. All right. Is N on the plane? Yes. Is E on the plane? Yes. So I could use any 3. Just pick 3. LAN. Sounds good. There was one rule. It doesn't really apply here. What was the rule we could not use?
You can't use the line.
Yeah, 3 on a line. So let's say that these 3 were connected. Just pretend that they were. You would not be able to say plane ELA or ALE or anything like that. All right, a segment, which I believe is on the next page. When we name a segment, what does the symbol look like above? Straight line. Does it have dots? Does it have arrows? No, neither. Just a straight line. And then, does it matter which points I pick? It does matter. Which do I have to pick? A and B. You have to pick the end points. A and B. Or the start and end point, however you want to call it. Or I could call this BA. That's it. All right, now we got rays to name. When we name a ray, what does the symbol look like above? Arrow to the right. Can we see the screen? Yeah. Arrow to the right, and then what will the first letter be for this ray I've circled? H. The starting point, and then G. And then the second one, got an arrow pointing to the right. My first letter would be A, and then B. All right, and then opposite rays. Opposite rays are 3 things, which is what make them opposite rays. Can someone name one of the things?
Opposite direction.
They point in opposite directions, right? That was the third. Opposite directions. What was another? One of them was that they had the same something or other.
Same start point.
Yeah, same start or end point, however you want to say it. And then the first one was that they had to be collinear, which means they have to be on the same line. So they have to be collinear, have to have the same end point, and they have to point in opposite directions. That's what makes them opposite. All right, so let's start. What do you think would be the end point for our opposite rays? C. So I'm just going to go around kind of like in a circle and figure out which rays could have an opposite ray. Does CH have an opposite ray? No. It would need to extend the other direction. Does CG have an opposite ray? Yes. What is it? CD. Wonderful. And then CB, does it have an opposite ray? No. It would also need to extend the other direction, and it doesn't. So that's all the review. At this point, you're going to need the ruler that is under your desk. Also, at this point, you can cross out the ruler that is printed on your, what's been doing, because it's wrong. So there's like rulers that you use in like elementary, and then there's like real rulers that we use in real life. So the one on your paper is like an elementary ruler. We're not going to use that. Okay. All right, so here's what's going to happen. Let's go ahead and look at our rulers. We're going to be measuring things. Okay? So I have a ruler on my screen so I can explain your ruler. The number 1 question I answer every year is, do I start at 1?
No.
No. Do you start at 1-year-old when you were born? You do not. All right, the other question I answer is, do I start at the edge of the ruler? Go ahead and look at my ruler and see if you do. You do not. So if you look, there's a longer line directly next to the edge of the ruler. Have we all found it? Do you have a ruler? All right. Do you have a ruler? All right, we'll go find one. There's one on every desk. You have one on you. There you go. All right, so that is where you're going to start. Okay? Other things to notice, my ruler, the ruler you have in your hands, that I purchased with my own money, so let's not break them, is this line looks like this, and then it has a 1 next to it. Does everyone see? All of them look like that. It would have a line, and the 2 would be next to it. Everyone see it? The long line is the new inch. Okay, not where the 1 is, but where the long line is. Everyone see? So, can anybody tell me how many dashes there are between each inch?
8. 16.
There are 16 of them. So, you can do one of two things. Well, in this class, I would prefer you do one. We're going to round to the nearest eighth. You have 16ths on here. So, if we look, this is a 16th, 1 16th, 2 16ths, 3 16ths, 4 16ths, 5 16ths, 6 16ths. Everyone see? What you can do is, if this is 1 16th and this is 2 16ths, what does that reduce to? 1/8. Every other dash is an eighth. So if you look, the eighths are a little longer than the 16ths, than the odd 16ths. Does everyone see them? Why do you think the one in the middle is longer than the rest of them? That's a half, all right? And then there's like a medium-sized one in the middle of the halves. That's the what? Yeah, you got 3/4, and then you got a 1/4. If that does not make sense to you, that's totally fine. What you can do is count eighths, and then you just have to reduce. So, like, this is 2/8, right? But what does 2/8 reduce to? 1/4, which you notice is like a medium length line. This is 3/8, and then 4/8, which reduces to 1/2. So everyone kind of see. You're going to count every other line. If you don't like that, you can count 16ths. You would just have to reduce more. Are we ready to start? Wonderful. Go ahead and line up on the M on number 1. I'll walk around and check. So line up on the M. Make sure it's straight or you're not going to have an accurate measure, you know. Some of these are going to be in between eighths. Just round to the nearest one. Your classwork does better at being exact. So this first one, it's bigger than, that's good, it's just a little crooked. Oh my gosh. What? Okay, I can get it. Alright, so it's bigger than 2 inches, right? So it's going to be 2 inches. Go ahead and write that. It'd be a big 2. And then it's some change, right? It's not quite 3 inches. It's 2 and some change. So let's look. How many eighths over is it?
6.
1, 2, 3, 4, 5, 6/8 over. What does that reduce to?
So
3/4. Did anybody not get that? I can look at yours. Yeah, that's easy. 3/4. So 1, 2, 3, 4, 5, 6, and then you reduce. So 2 full inches and 6/8, which reduces to 3/4. If you look at the second one, so go ahead and move over to the left. Does it go past 1 inch? Yep. Does it go past 2 inches? Yep. Does it go past 3? No. So it's 2 inches. All right, and then how many eighths does it go over?
2.
Yeah, depending on what yours is a little farther. You want to scoot it back that way. It's, what did you say, 2/8? What does that reduce to? 1/4. So 2 and 1/4. All right, and then the third. Is it bigger than 1 inch?
Yes.
Yes. Is it bigger than 2?
No.
No. That was a nice one, right? It's 1.5. Yep. And then the last one. It is 2 inches, and then I think it's exactly 2 1/16, but we can round up to the 1/8. So 2 1/8. Yeah. Does anybody know how they measure in like trades? So carpenters, contractors, plumbers, electricians. Does anybody know how they measure? They don't measure to 16ths. Even smaller. What's smaller than a 16th?
32.
30 seconds, yeah. So So my husband works with your brother. Did you know that?
Right. What's this?
Yes, that one. They're at the same job site right now. Anyways, so my husband works daily, and he can't, if he's off by a 32nd of an inch, like, he has to redo it, or has to tell someone that they need to redo it. So we're just going to stick with the 8ths for this class's purpose. We do use rulers the rest of the year, off and on. But we do have projects that we do in class that are a little artsy that we would use the ruler to measure. But if you don't have any questions, we're free to move on to the next page. All right, so we're going to learn 2 geometry words. One of them is a postulate. In geometry, so you can just put rules that are accepted without proof is a postulate. It's a rule accepted without proof. A rule accepted without proof. A rule accepted without proof. And you're like, why do we care? You're going to see this word, and you'll probably become numb to this word because of how much you'll see it. But one of them is, and it's fairly obvious, take 2 lines. Will a line ever bend or curve or anything? Straight line, right? One of the postulates in the world is that 2 lines will intersect once and then never again. Do we all accept this to be true? Yeah, that's it. You wrote it on page 3, the top page 3. All right, but some things we have to have proven. They're called theorems. So they're rules that are proven. They're called theorems. So rules that are proven. You should have learned one last year. I'm pretty sure that you did. Does anybody know what theorem I'm talking about? The Pythagorean theorem. So if you walked up to someone and said, well, a squared plus b squared equals c squared, and you expected them to believe it for the rest of their life without any proof, that's not going to happen. So theorem has to be proven in order for it to be believed. The next 2 blanks, they're very important to geometry. Congruent segments are segments with the same length. So congruent segments are segments with the same length. Congruent segments are segments with the same length. That is the 3rd blank. They're segments with the same length. You're going to hear the word congruent a lot. You'll see congruent polygons. Does anybody know what a polygon is? That's a pentagon. So poly just means, yeah. So it's a polygon is a shape, right? So there's such thing as congruent polygons, congruent triangles. What do you think? What makes them congruent? The same length, the same angle, same everything. All right. So congruent segments is where we're going to start. I'm ignoring it. If you ignore it too, you can say the length of AB. We'll talk about it in a second. The length of AB is equal to length of CD. Or this is what the purpose of the word congruent was made for. This symbol is the congruent symbol, and I believe you have a blank for it. You draw a squiggle and an equal sign underneath. So I would draw it. It is a squiggle and an equal sign underneath. All right. You have a question on your quiz that'll look something like this, and I'm going to ask you what this says. This says that segment AB is congruent to segment CD. That's all it says. This is the correct geometric way to say 2 lines are the same length. In this picture, they look like they're the same length, right? The thing about geometry is that you can't just say, well, they look like, or that point looks like it's in the middle. It must be the midpoint. That's not how it works, and we're going to talk more about it tomorrow. What do you think shows that these 2 segments are congruent to each other? Just take a guess. The what? The little dash. This dash means that they're the same length. So that's how it's proven to us in geometry, which is what that's going to say. We'll talk more about it tomorrow when we talk about midpoints. But first, we're going to compare segments to see if they're congruent. We're going to plot some points and then see if 2 segments are the same length. So before I plot points, what do I need?
Numbers on the line.
Well, before that,
The center.
I need the center. How do I draw a center? You just do an x-axis and a y-axis. You can put numbers on the axis. I think it's a hot mess when people do that, but do you? I usually just draw straight lines, x and y-axis. Which of these is the x-axis? The horizontal one is x, and then the vertical is the y. All right, so every coordinate point is made up of an x and a y. The x will tell you whether to go left or right. How will I know whether to go left?
Negative.
If it's negative, and then how will I know whether to go to the right? Positive. And then the y, if the y is,
It'll go down.
yeah, so negative is downward and then positive is upward because heaven is in a positive direction. You want to go up. And then, that's negative. All right, so this is going to end up looking like two segments, right? So what 2 points are going to connect for my first segment? What do we think? What 2 segments am I comparing?
JK,
So JK means that I'm going to connect J and K. And then LM means I'm going to connect L and M. So I'm just writing that so I know when I go to graph. We're going to graph J first. So J has -3 as the x. So from the origin, am I going to go left or right? Don't put a dot there. I'm just trying to show. You're going to go to the left. How many?
3.
1, 2, 3. And then I'm going to go up. 1, 2, 3, 4. So all you should have is a dot up here that says J. That's all. I only put a dot to show because I'm recording, remember. I'm just trying to show them where I'm pointing. So we have J. Now we want K. The x is 2. So starting again from the origin, I'm going to go to the left or to the right?
All right.
To the right, 1, 2. And then am I going to go up or down? Up, 1, 2, 3, 4. Okay. Connect the dot. So we have one segment. Make sure you have J and K labeled. Then we'll move on to LM. Starting from the origin, we have L, which is 1, 3. So from the origin, am I going to go left or right? To the right 1, and then up or down? Up, 1, 2, 3. So I got L. And then M, X is 1, and Y is -2. So am I going to go left or right? To the right 1, and then down 1, 2. Then again, connect the dots. We don't have to overcomplicate this. How can I figure out if they're the same length? Count the boxes. These are horizontal and vertical lines. We can just count the boxes. So 1, 2, 3, 4, 5. And then 1, 2, 3, 4, 5. What did the question ask for?
Determine whether JK and LM are congruent.
Correct. We want to determine whether JK and LM are congruent. So we figured out, are they congruent? Yes. So now we want to state that they're congruent. So JK is congruent to LM. That's it. JK is congruent to LM. What if they weren't congruent? What do you think we would do to the congruent symbol? Slash through it. Yep. Good. All right. So now we talk about something very important. This is where they argued with me about football. All right. But before we get there, let's refresh what this symbol means. What does this mean? Segment AB. But what you're going to see in this section is nothing above it, just AB. And what I want you to write down is that this means length of segment AB. So if there's no line above it, it means length of segment AB. So if you see AB with no line above it, I hope you're writing it down. If you see AB with no line above it, it means length of AB. Why does this matter to me, Miss Marshall? Because I'm trying to help you. On one of the quizzes eventually, or tests, you'll have a section that looks like this and like this. Was it this one?
Mm-hmm.
Yeah. All right, so let's talk about the differences between the two of these. Okay, this one says segment AB, and then what does the symbol mean? Is congruent to. So what do you think the answer would look like segment AB is congruent to another segment, right? So we could just say CD. Whereas this one has no line above. So what does this one say? The length of AB equals, what do you think the answer would look like? The length. So it would look like a number. So make sure you can tell the difference. Line above is just naming a segment. No line above is asking for a length. Okay, and you can see it at the bottom of this page on example, 3? It'll say find DF. That means the length of DF because there's no line above it. All right, we'll talk about it. So it's just going to stay at the top of the page. Let's talk about the segment addition postulate. This is a postulate because we all agree for it to be true. You'll find a bunch of blanks. It'll say if blank is between blank and blank. You're going to fill it in. If B is between A and C. So you're filling the blank. If B is between A and C, then the length of AB plus the length of BC equals the length of AC. You already know how to do this, and I promise you that you do. That's why it's in 1.2. Mike, if B is between A and C, then the length of AB plus the length of BC equals the length of AC. Are we okay using a football field that is 100 yards, or do you want to use 120? What do you want to use? We're going to use 100 because that's really easy, right? Okay. Let's say the full length is 100. All right? Pick an easy number, a smaller number. We're going to fill in AB. 20. All right, it's saying that AB plus whatever BC is equals AC. What would the length of BC be? It would be 80. How did you know that? Because you subtract. Because 20 plus 80 makes 100. That is the addition segment postulate. That's it. Or the segment addition postulate. Are we all okay with it? Wonderful news. It's just going to show you in other terms. Here's AC. It is the length of AB plus the length of BC combined. Brings us to our two examples. We're going to find the length of DF. All right, the length of DF. We know from D to E is 23, and from E to F is 35. So what do we do to find the full length? Add them together, that's it. 23 plus 35 is 58. So what you're going to write is the length of DF is 58. So go ahead and write DF. I want you practicing without the line above DF, which means the length of DF is 58. Circle it, box it, highlight it. I don't care. Just show that that's your answer. All right, the second one, find the length of GH. We know the full length from F to H is 36. From F to G is 21. How do we find what remains? Subtract. 36 minus 21 is 15. So the length of GH is 15. We feel good about it? Wonderful. Turn the page. So now you just have a picture behind it, but it's the same idea. The cities shown lie on the map approximately in a straight line. Find the distance from Tulsa, Oklahoma to St. Louis, Missouri. What is the full length of our trip? 738. So how much of that trip have we already driven? 377. So how do I find what's left? Subtract. What is 738 minus 377? It's close. 361 miles. If you had 3 highlighters and you want to color code what we're about to do, you can. You don't have to. I'm going to do it. So if you want to as well, you can. So this looks harder. It is a little bit. It's got some algebra. But I will tell you it's exactly what we've been doing. The only thing is we don't have a picture, right? But we can draw one. It says points A, B, and C are collinear. What does collinear mean to me? They're on the same line. Point B is between A and C. What does that mean to me? What order does it go in? A, B, C. Because B is between A and C. So we're going to draw a straight line with 3 points. Does it say that B is in the middle?
Yeah.
It just says that it's between. Somewhere between. So Just keep that in mind whenever you're doing these. Unless it said B was the midpoint or something like that, we don't know that. So we have A, B, C. This is where if you have 3 colors, you can do what I do. I'm going to take one color. Our goal is to find X and then find some lengths. I know that AC is 3X plus 3. So I'm just representing that from A to C is 3X plus 3. Then I know that AB is negative 1 plus 2X. And then we know BC is 11. So, if you remember, let's go back to the basics. Give me 2 numbers. Easy numbers. 10 and 5. Okay. All right, let's say we had points A, B, and C. What would the full length of the line be here? 15. Because we learned that if you take the length of AB and you add it to the length of BC, then it will equal the length of AC. Right? That's what we learned. 5 plus 10 equals 15. We're going to use the same theorem here. I switched up the colors on accident. But we're going to use the same theorem. All right, so what is the length of AB in my first question? The length of AB. Negative 1 plus 2x. And I'm going to add it to the length of BC, which is 11. Them added together will equal the length of AC, which is 3x plus 3. We're still using the same property that we were using before. These 2 segments add up to the whole segment. Are we okay with that? Are you fading or are you struggling? Okay. All right. So now we just solve for x. Okay? So remember, don't call after midnight. D stands for distribute. We don't have that. C stands for combine like terms. Do we have any of those? We do, which is negative 1 and 11. Negative 1 plus 11 is 10. All right, so I know that all last year you had to have x on the left side, yes? I am going to tell you that there are many ways to solve this problem. We all agree? I do not care. But when we're in class, I like to do the least amount of work possible. Are we okay with that? So I don't want to move 3x to the left side. Can someone tell me why? Then it would turn into a negative. Then I'd have to deal with that later. I do not wish to do that. I always move the smaller x, which here would be 2x. So I'm going to move the smaller x. How do I move the smaller x to the other side? Subtract 2x. There's not really a law in math that says x has to be on the left side. It just, there's no need. 3x minus 2x is just x. You're good. Plus 3. Yep, subtract 3, and that makes 7. You don't have to flip it. This is the answer. I'm just going to leave it like this. But if you had it flipped the other way, I'm not going to mark it wrong either. X equals 7 and 7 equals x. They're literally the same thing. So we found x. It says find the length of AC, find the length of AB, and find the length of BC. So let's start with AC. In the beginning, what was the length of AC? 3x plus 3. But don't we know the measure of x? What is it? So we could plug it in. This is really 3 times x plus 3. So 3 times 7 is 21 plus 3 is 24. So AC is 24. The length of AB, let's do the same thing. What did the length of AB used to be? Negative 1 plus 2x. So we're going to plug in. X is still 7. So do we add first or do we multiply first? Multiply. 2 times 7 is?
13.
Minus 1 is 13. And then we technically already know BC is 11. What's a way I can check to make sure I'm correct? Yeah. AB plus BC should make AC. So AB is 13, BC is 11. 13 plus 11 is 24. Got any questions, comments, concerns? Wonderful. We're going to do it again. We can draw a picture again. So it's the same setup. We have an A, a B, and a C. B is somewhere between them. This time AC is 22. BC is x plus 14. And AB is x plus 10. We're ready to start. So how am I going to start the problem? Correct. X plus 10 plus...
Plus x plus 14.
Correct. Plus x plus 14. So you want AB plus BC, and then we'll equal AC, which is 22. So we want to combine like terms first. So what are some like terms we have? Yeah. X plus x makes 2x, and then 10 plus 14 is 24. All right, and then what do I do next? Subtract 24. 2x equals negative 2. My last step. Divide by 2, and x equals negative 1. That is part of the answer, so solve for x. So make sure you're circling that or something. Then it wants to find lengths. So I want to ask you a question. Can you have a negative length? No. Think about it. If you drive 20 miles to Grandma's house and 20 miles back, do you drive 0 miles? No. Distance and length are never negative. You'll never take out a tape measure and say this is negative 7 feet long, right? So I have a negative x. We just want to plug it in and make sure we don't have a negative length. Okay, so let's start with AB. What was the length of AB? Well, x plus 10. So negative 1 plus 10, which is 9. And then the length of BC was x plus 14. Negative 1 plus 14 is 13. And then you can check yourself, because 9 plus 13 is 22.